section for 6. So like I said, this is part 2 where we learn about secant and cosecant. When we do part 3 on Monday, we're going to kind of put tangent, cotangent, secant, cosecant, all 4 of them together. I think the plan after that is probably on Tuesday to do some review over 4, 5, and 4, 6. And then maybe Wednesday, possible quiz over 4, 5, and 4, 6. So just letting you know that ahead of time. I'm going to do this lesson very much like I did the lesson yesterday. I'll start by giving you what the parent graphs look like. Then we can make a list of all the important stuff again, and then we'll get to some examples where we have to change some of it. Now, when you draw your coordinate plane for secant, leave a little bit of room on the left. I am going to label one x value on the left and then 2 on the right. So I got a little bit more room over there on the right side than I do on the left. Okay, these are different than tangent and cotangent, so follow closely. I'm going to come over here on the left side, and the first important x value that we're going to have is negative pi over 2. And the next one is positive pi over 2. So to get that evenly spaced, I'll try to leave about the same amount of space from 0. Although I want to point out 0 is not really on my list of important values. I'm just kind of using that as something to go by to space these out. And the last important x value that I'm going to put up here is 3 pi over 2. But watch, the distance between these x values should really be about the same as the distance between the last 2. So again, it's kind of confusing because 0 is not really on your list of important x values. We might have something there here in a minute, but for now, it's just negative pi over 2, positive pi over 2, and 3 pi over 2. So, cotangent, tangent, they both had 2 asymptotes. We're moving up in the world today because secant and cosecant actually have 3 asymptotes. Every single value that I just put up here is going to end up being a vertical asymptote. So you can draw dotted lines through all 3 of those values. Mine look a little slanted. Try and make those look straight if you can. Now the amplitude here, it's a parent graph, so the amplitude is just 1. You can just use the lines on your paper for that. And then you'll start to notice that the parent graphs for secant and cosecant actually are sort of in 2 pieces. So the first part of the graph, you're going to come halfway between these first 2 asymptotes, which actually puts us at 0. But then once you're halfway between, move up to wherever your amplitude tells you. In this case, the amplitude is 1. So I move up to positive 1. And that's actually the only point that I would like for you to graph. The rest of it gets filled in kind of like a parabola, actually. It's sort of like a parabola opening up at 1. So that's the first little chunk of the parent function. And then on the other side, come halfway between these asymptotes. I'm not going to ask you to label that number or figure out what that number is. Just put your pencil there. Then on this side, you're going to go down to wherever your amplitude tells you. So in this case, down to negative 1. And instead of opening up, this is kind of looking like a parabola. It's not really a parabola. I'm just comparing it to that. But this is sort of like a parabola opening down on the other side. Now, the shape of this is actually going to be the same with cosecant. The asymptotes will be in different places, but the shape is the same. One part up here opening up, another part down there opening down. We will have an example today where it flips, but I just want to tell you about that real quick while I'm thinking about it. If you have a negative in front of your function, instead of just flipping it over where it's at, you actually flip it over and scoot this part all the way down to the opposite amplitude. So the amplitude on the other side, this one gets flipped over and scooted up to wherever the amplitude is on this side. So it does a complete flip anytime there's a negative out front. We'll see more about that here in a second. Now again, this is all stuff that you could get off of the graph, but I like to just kind of list it out because you saw yesterday, if the period changes, you have to take the old important stuff and divide it all by b. So here's the important stuff for secant. You can see it right there. The left asymptote is at negative pi over 2. Yesterday, the next part was a center point. It's not really a center point with this graph. I'm going to just call that a center asymptote. It's the one in the middle. That is at pi over 2. And you can see right here, the right asymptote is at 3 pi over 2. Important stuff for secant. Later on, when we do our examples, if the period changes, again, we'll take that old stuff and divide it by b. Okie doke. I'm going to next give you the graph and the important stuff for cosecant. So this says y equals cosecant of x. Now, for the coordinate plane on this one, we're not going to have anything to label on the left. It's all going to be pretty much on the right side. So that's kind of different than secant. All right, we shouldn't really have to label 0 because we all know where 0 is, but I'm going to put it there just to show you that it is going to be one of our important x values. Then I'll come all the way over here and label that last value 2 pi. And so right in the middle there, you would have 1 pi, or just pi. So same thing, all three of these values are actually vertical asymptotes. You don't have points there. We don't have anything there really. It's kind of like a boundary line. Then amplitude is 1. The amplitude is what helps you graph your points. You know from secant that the first part's up here, second part's down here. It's the same thing with cosecant. Halfway between these asymptotes, I go up to wherever my amplitude is, and I draw what looks like a parabola opening up. And then halfway between these asymptotes, I'll go down and put a point wherever my amplitude tells me. And again, that kind of looks like a parabola opening down. It's kind of nice with secant and cosecant because they are so similar. The shapes are exactly the same. It's just that the asymptotes are in different places. So, important stuff. For cosecant, you can see it from the graph, but the left asymptote is at 0. Again, I'm pretty well just listing important x values here. So the left is at 0. The center asymptote, CA, if you want to call it, that is at pi. And right asymptote is at 2 pi. Looking good. Now I'm going to put something else up here that I kind of did yesterday. Once I showed you what tangent and cotangent looked like, we saw that the period for those two functions was pi. It went to pi before it started to repeat. Well, take a look at the period here. The cosecant graph, and actually this is true for secant as well, it goes all the way to 2 pi before it starts to repeat. The next little chunk over would be that part, then that part again, and it just keeps doing that forever and ever. So to summarize that, I just put back up here that the period for y equals secant of x and y equals cosecant of x is 2 pi. The period is 2 pi. So that means when we go to our examples here in a minute, anytime you have to find the period for secant and cosecant, you end up taking the 2 pi divided by b, kind of like we did with sine and cosine, instead of just pi divided by b. So we're going back to that original formula for the period. Okie doke. We've got what we need now. So directions, again, are the same as they've been for the past, I don't know, week probably now. Clearly state the amplitude and period, sketch a graph, include one full period, label all of the important spots. You can say same as earlier if you want to. Save a little bit of time there. Again, amplitude is absolute value of A, but the period, we're back to 2 pi divided by b, because we saw on the graphs earlier that the period for secant and cosecant is 2 pi. Okie doke. I'm going to go ahead and put the first one up here. Like I said, you've already got those directions somewhere in your notes. So first one, y equals 1/2 secant of 2x. 1/2 secant of 2x. Amplitude first. Absolute value of 1/2 is 1/2. So that's not too bad. Now, like I said earlier, to find the period with secant and cosecant, we're back to 2 pi divided by b. So I can see up here, b is still that number in front of x. So b is 2. And then it turns out that the 2's go away and you're just left with pi. So this is the same idea as yesterday. Anytime the period changes from what the parent graph was, anytime the period changes, you have to go through your old important stuff, divide all of that stuff by b to get your new important stuff. Now pay attention to what function we're working with. We're working with secant. So if you go back to the parent graph for secant, where was the left asymptote? Negative pi over 2. What am I going to divide that by? Yes, I know. It's so hard to remember. We divide it by b. It's so tempting to divide it by pi because that's like the last thing that you did. But yes, it's always dividing it by b, that number in front of x. So keep, change, flip. I'll end up taking negative pi over 2 times 1/2, which makes negative pi over 4. That'll be our new left asymptote. All right, I'm going on to the center asymptote, CA. It used to be at pi over 2. Divide that by 2. It's actually the same work that you did up here, but now it's positive. So positive pi over 4. And the right asymptote used to be at 3 pi over 2. divide that by 2. So again, it's like multiplying by 1/2, and you get 3 pi over 4. Very good. Those are the new x values that we need to put on our x-axis. And try to remember what I said earlier. The distance between the first two asymptotes should be the same as the distance between the last two. So I'll try to keep that as even as possible. If this is negative pi over 4, then that would be positive pi over 4. And then here I go. That distance, keep that about the same to label your 3 pi over 4. All right, here comes one vertical asymptote. Got a little crazy with my dots there. Here comes another vertical asymptote, and there's the last one. So amplitude is 1/2. That's different than 1, obviously. So make sure you label that. You can go up to a line if you want, but still label that 1/2 and negative 1/2. So here I go. I'm going to come halfway between these first asymptotes, and I'll go up to wherever my amplitude tells me. So that's the first chunk of my graph. Halfway between here and down to wherever my amplitude tells me, that would be the second chunk of your graph. Okie doke. Main things to remember, it's 2 pi divided by b instead of just pi over b. And dividing by b is what you have to do to get your new important x values. Any questions about that one? All right, I've got 4 total today like I had yesterday, so this lesson usually goes a little bit quicker. Number 2, y equals negative 2 secant of x. Negative 2 secant of x. What would the amplitude be? 2. Very good. I am pointing out that it is flipped here because of the negative, but when I take the amplitude, it's always absolute value of a. So that is 2. And hey, this is kind of nice. To find the period, I have to take 2 pi divided by b. b is just like a 1 here, so 2 pi divided by 1 is just 2 pi. Now, is this any different than the period of the parent graph? No. So I wrote this down up here in case you want to put it like this in your notes. It says, since the period hasn't changed, you don't have to find new important stuff. You don't have to take all the old stuff and divide by b. And so that's kind of something new here. I don't think we ran into that yesterday. If the period doesn't change, you don't have to divide everything by b. You could, if you wanted to. Let's say you forgot about that and you go ahead and do it. It's fine because all you would be dividing by is 1. b is just 1 here. And if you divide something by 1, you don't change it. So it would just be a little extra work. You don't want to do it though if you don't have to. So I'm not going to. I'll go ahead and start to label all of my important stuff here. This is secant. So it's like what we had on the last one, but back to the old values. This is negative pi over 2, positive pi over 2, and 3 pi over 2. Don't forget it's flipped, so we'll have to kind of watch for that whenever we go to do our points. Amplitude is 2. You can just use the lines on your paper for that. So here I go. Usually with secant, It's up right here, down right there. And the amplitude is 2. So this part would be up here at 2. That part would be down at -2. When it flips, it does a total flip. This part is now down here at -2, opening down. I'm going to make that look a little bit better. Down here at -2, opening down. And then this part used to be down here. Now it's all the way up at +2, and it's opening up. So don't just flip the parabola part over. You do flip that part over, and then they kind of switch positions. Okie doke. Any questions about that? By the way, that's also how you would flip a cosecant. I don't think I have that in the notes today, but it do the same thing. Totally switch positions. All right, last two here. Example 3, I always like to throw in a fraction one because these are kind of confusing. Y equals cosecant of x divided by 2. All right, well, amplitude is 1. For the period, I have to take 2 pi divided by b. Anybody know what b is? 1/2. Yes, 1/2. So 2 pi divided by 1/2. I'm going to keep, change, flip. So that's actually going to turn into 4 pi. The period here is different than the parent function. It's just like twice as big. So now I have to take the old stuff and divide them by b. This is cosecant, by the way. So where was the left asymptote for cosecant? 0. If you go back to the parent graph, left asymptote was at 0. Divide that by b and you still get 0. Now, center asymptote, where was that for cosecant? Yes, pi. So take that divided by 1/2, and you might need a keep, change, flip right here. Keep the pi, change it to multiply, flip over that fraction. You end up taking pi times 2, which is 2 pi. And right asymptote, you kind of do the same thing that you did up here. 2 pi divided by 1/2, that works out to be 4 pi. It's easier to see the period on a cosecant graph because most of the time it starts at 0. So whatever the period is, that's usually where your right asymptote is. So 0, I'll call you 4 pi. I'll call you 2 pi. Now, these are the boundaries. Make sure that you're drawing these, by the way. Had a question about that yesterday. Do I have to draw the dotted lines? Please do. They set up your boundaries so you know what you can't cross. This is a 1. That is a -1. So it's cosecant. Go ahead. That is fine. That'll be fine. As long as they're there, yes, as long as I can see them somewhere, that's perfectly fine. All right, I'm not flipped this time, so halfway between here, I'm going to go up to 1. That is my amplitude. So a normal looking cosecant graph. I've got one part opening up, and then the last part over there is opening down. Most important part here are the asymptotes. Getting those in the right place, then you can kind of fill in the curves pretty easily just by using your amplitude. All right. Now I want to do one more problem here that has some kind of a shift to it. Haven't really had that happen yet today. So number 4, a tad bit different. Y equals cosecant of pi x minus 2. Cosecant of pi x minus 2. Now, does anybody know what that minus 2 is going to do to our graph? Yes, down 2. It's not on the inside of the function. It's technically on the outside. So that's going to be something I don't even worry about until the very end of the problem. I'll take all my points and move everything down 2, but I'm not going to worry about that just yet. Amplitude is 1. Now for the period, I have to take 2 pi divided by b. What is b? Pi. So 2 pi divided by pi, goodbye pi, those cross out and you're just left with a 2. So this is one of those problems where you don't have pi anymore to work with, you just have normal numbers. So left asymptote for cosecant used to be at 0. Take that divided by pi or take that divided by anything and you still get 0. Now the center asymptote was at pi. Anytime you take a number divided by itself, you just get 1. And right asymptote used to be at 2 pi. So this is like what happened right here. Take that divided by pi and you just get 2. All right. Now don't let me forget that I am going to have to move everything down 2. So let's see what I've got up here first. That's a 0, a 1, and a 2. Amplitude is 1. So I'm going to set up my asymptotes here. Okie doke. Then what am I doing? Well, first thing I'm going to do is I'm going to graph this function without the minus 2. So y equals cosecant of pi x. You guys know me. I don't like to do too much at once. So I'll draw this in and then I'll worry about taking everything down 2. Now that reminds me, if I'm taking everything down 2, I might want to do a better job of labeling on my y-axis. So I'm going to throw on another couple values there. And here I go. This is what my graph looks like without the minus 2. This would be up here at 1. That's down at -1, but here we go. Down 2. Hey, question, if I move it down 2, should I flip it also? No, sometimes that's tempting, but shifting something up or down doesn't change the way it opens. It just moves it, and that's it. So that second part should be all the way down at -3, and it still opens down. Okie doke. Any questions about that? You may have one in your homework that moves up also, so you can kind of do the same thing, just shift everything up. We are still in the textbook here from page 311. We're going to do numbers 15 to 20. But like I said yesterday, use our directions. I don't think the book goes into as much detail as we do, so just follow what we did in our notes.